Kia ora everybody. So I'm just making a video that's me going through a full practice assessment because you guys now have your practice assessment. Now I'm going to go through the pet practice assessment and you guys are going to be going through the knife practice assessment, but I'm going to go through it as I suggest that you guys do it at home so that you're able to follow the steps. So what you're going to do is you're going to get this up, which is it says practice simulation assessment. So you'll get this up and you should open these three things in 3 tabs. So you hold down Command or Control or whatever you're using. Now I'm not going to open that practice assessment, but I am going to open the marking grid because that's what you're going to use to make sure that you're ticking everything off and you're going to get your marks. So this marking grid's fairly straightforward. I suggest you go through achieved first and tick all those boxes, then start going and doing the merit boxes, then start doing the excellence boxes. Now that's even if you're aiming for an excellence, I would still suggest that you guys do that. If you're only going for achieved, obviously you don't need to waste your time doing that, but I think everyone in this class is capable of getting at least a merit, so you may as well be trying to tick these off. Okay, so I'm going to be going through the pet simulation. We already started it in class, but I'm going to quickly go over it again. So the first thing you need to do is you really need to make sure you read the question. A family is going to the pet store to choose 12 pets. There are 4 types of pets with these probabilities. Investigate the probability that the family gets all 4 types of pets with 12 pets or fewer. So see here that we've got a problem, and our problem is to see if we get all of those 4 animals in a simulation of 12 pets being purchased. Okay, so what we do is we have a look at the plan first. We did this in class, so we assigned probabilities. They were given above, so all I've done is just translated this into the table. Dog 0.4, cat 0.3, fish 0.2, bird 0.1. All right, you then allocate random numbers, and so because these nicely divide into 10, like 0.1 is 10 times 0.1 is 1, right? I've randomly allocated 4 of those numbers to dog, 3 of those numbers to cat, 2 of those numbers to fish, and then 1 of those numbers to bird so that you can match the probabilities accordingly. The tool we're using is Google Sheets, so I'm going to open that up right now. Oops, no, we don't want a marking grid. We're going to use rand between from 1 to 10 so we can get those correctly allocated probabilities, and we're always going to do 50 trials because that's necessary to get the marks. So you just say that we're doing 50 trials, and the reason we are doing 50 trials is because we want to do a big amount so we can get really accurate probabilities, but also we don't want to go too big so that we have to keep going through and counting manually if all the pets are there. For more than 50 trials, that would take you guys ages. So I think 50 is just a nice in-between number. We did this in class. I am going to use the rand between function to randomly generate pets to simulate what the family could choose. They are selecting 12 pets, so I will do 12 random numbers in each row. I want to do lots of trials to get a good idea of what possible outcomes can happen, so I will do this with 50 trials. So let's have a look at our marking grid. Now, I'm actually following, this is a really helpful thing that Miss Liu put up on the classroom. She's got this simulation example, so I'm just following through exactly what she does here. So you guys can use this as well. It's sitting on the classroom and available for all of you guys to use. She goes through, so notice what she does is she tells you to do these things and she references the marking grid all of the time to be able to do that. So her description of the simulation was, one trial consists of generating 12 random numbers. Each number represents a pet the family gets from the store, and then I will check whether the family can have all 4 types of pets in this trial. Then I will move on to the next trial and repeat this process. In total, I will generate 50 trials. So see how she's gone to the marking grid? She's checking that all of these things are going to be ticked. Allocated random numbers correctly, identify the tool, description of a trial including the finishing point, and then the number of trials. So see how she goes to the marking grid and she just copy pastes and makes sure she's ticking those boxes, because that's how you pass NCEA with the grade that you want to go for. Okay, so let's go back to it. So We now need to go do the data section. So we're going to quickly do that. So I'm going to open a new Google Sheet and we're just going to follow those instructions. So the first thing we do is we're going to start with the numbers 1, 2 down here, and then you can select both of those and drag down, and I'm going to drag down to row number 51, so then I have 50 trials. And I'm just going to put trial number up here. So over here I'm going to put the pet. So this is the first pet that they buy, this is the second pet that they buy, and you can actually use that same thing and you can drag across. Now I'm not so good at English, so I'm just going to guess. Yes! What are the chances? Okay, so what I'm going to do is I want to make this a little prettier. So I'm just going to resize these a bit because there's no need for them to be so big. Yeah, that's nice. So let's have a look at the question again, because we're going to try and work out what it is I'm trying to do. So you can keep referring back to this. Investigate the probability that the family gets all 4 types of pets with 12 pets or fewer. So I'm going to ask the question on my sheet. I'm going to say all 4 pets, question mark, and then I can answer that with yes or no's. So I'm then just going to bold these just to make it look a little prettier. Yep, looks good. So then we've already said that we're going to use rand between, and we said we were going to do between 1 and 10. So let's put that in there. Oh, it suggests an autofill, so let's just do that. It's actually exactly what I wanted to do, so that's great. So they've all generated nicely, and we're going across to M, remember? So now we've got random numbers all through here. So once we've done that, remember we want to lock these in, because every time I say I go through and I count that and I go yes, it's going to change all those numbers. So we want to lock those in. So we're going to have to do a paste special. So I'm going to click up here. I'm going to go Command C. I'm then going to start a new sheet down here. And then I'm just going to go, ooh, not Command V. Command Z. I'm going to go Command Shift V. So Command Shift V does a paste special. So it's the same as going in here and where are you? Paste. See how there's paste special, and it only brings the values rather than the formula as well. So I'm going to resize this and make it pretty again. So I probably shouldn't have bothered resizing before because it's just going to get corrected anyway. Okay. And then I'm going to bold these out again. So maybe you should do these fix-ups afterwards. Okay. Then what I'm going to do is I'm going to select all these and I'm going to get my colors going. So I'm going to select all them, only the internal numbers. And I'm just going to make this drop down work. And I'm going to do a conditional format. So I'm going to go to conditional formatting. And now I want it single color. And I want it if the number is, what we're going to do is I'm going to have 2 things open at once. So I'm going to drag this over. You can do this on Windows as well. Where is my thing that I'm doing? Here it is. I'm going to get this over here. And I just want to make it so I can see what colors I've used for each thing and what number that represents. So now I can have that up over there. So then I can see the numbers from 1 to 4 represent dog, and that's yellow. So I'm going to go yellow. And I'm going to say if it is between the numbers 1 and 4, and that becomes dogs. So those are all dogs that the family's done. I'm going to do another rule. Cat is teal, so I will select teal, and I'll say is between, and cats are between 5 and 7. So I'm going to put in 5 up to 7. Done. So that's all the cats coming up in teal. So then I'm going to go is between, and I'm going to go is between 8 and 9, and that makes a fish, and fish is this nice pretty magenta color. So those are all my fishes showing up. And then I'm going to go to green, and I'm going to make that bird, and bird is actually, we can do this, text contains 10. I'm being a little bit lazy. Maybe I should have just done is between so people don't get confused. 10 and 10. And those are all the birds. So these formatting rules are all done and dusted. So we can be confident that they're looking good. So let's drag this over. Nice. So then what you do is you're going to have to go through and manually count. I'm going to make a video about how I solve having to manually count this later, but that's only for buffs. So what I do is I go yellow's there, yes, purple's there, yes, teal's there, yes, green's there, yes. So yes, all 4 pets. What about this one? Does it have everything? Yes. This one here, does it have everything? Yes. Does this one have everything? No, it's missing a green. So no. So then you go through all of those until you finish it, and then what you're going to do is make another little table, and you're going to say number yes, and then number no. So maybe your number yes could be, maybe you had 36 that were yes, and then you had 14 that were no. So then probability of all 4 is going to be 36 over 50, which is the total amount. So we can actually probably put an equals and do the actual maths. Equals 36 over 50. So then that gives you the probability, and you can make a little table with that. Once you've done this, then I reckon you should zoom out, because they need to get a copy of that. So let's zoom right on out. And we're going to have to get that and do a snip. So you can snip by doing typing in the word snip on a Windows computer, or on a Mac it's Command-Shift-4. On a Chromebook it is, I think it's Control-Shift and then line box is the snip for that one. I just can't remember. That disappeared. I should have got it faster. Dang it. Sorry, we'll find it. It's right here. And then I just Command-C that, and then that is going to be my data for this. So we've actually done everything we need in the Google Sheet now. So what they want you to do is they want you to chuck a picture in there. So that's a picture of my data, and then we need to link that as well. So let's get that back up. Yeah, and they want a link to this. So I'm going to call this my pet simulation for Z. Doesn't really matter. Your one's going to be the Google Sheet that you use on the classroom. So I just made my own, but you guys are going to have to use the Google Sheet that we give you on the classroom. So I'm going to copy that link, and it's copied, and then I will put it into my thing. Okay, cool. So that's a link there. I've got a picture. So let's just have a double check and see if we've done what is necessary. So we've used the tool, we've allocated the random numbers correctly, we've got a description of the trial, the number of trials is stated, the outcome of the simulator are recorded correctly with sufficient clarity. So mine's not quite finished. You guys would need to actually go down and finish all the yes, no's. The outcomes of the simulation recorded with sufficient clarity. And then that outcome that I did over here is very clear. One of the following found. So you're going to need to find a probability for this one. So that ticks that. So that's my data and my analysis finished. So what I haven't got yet is an assumption that needs to be discussed. If I want to, in plan and data and analysis, the first part, we need to start thinking of some assumptions. So let's have a think about what might be some good assumptions for this pet simulation. So what might be some assumptions, and where might I put them? Problem. I'm going to make a new thing called assumptions. Why not? So in here, command backslash. I want to get these fonts the same. Okay, so what are some of the assumptions that you could say? We are assuming that once the family picks a certain pet, the next pet, the probability of them picking that same animal directly afterward is not affected. for example, if you purchase one fish, the chances of selecting another fish probably increases as the marginal cost of setting up a fish tank means. So, for example, if I buy one fish and I buy all of the tank and the filter and the snails and everything you need for a fish, you're probably going to buy more fish to fill out that tank. Means that you will probably want to fill up the rest of the tank with more fish, right? So that could be an example of an assumption. And see how I've done it really specifically and in context. Right, so you could start doing assumptions with that. What else are we missing here? The allocation of random numbers to outcomes has been clearly explained. So I haven't done that yet. So how would I explain why I picked these outcomes? So maybe I put this down under here. The reason that I allocated the numbers 1 to 4 for dog is because there are 10 numbers total, and if 4 of those numbers are for dog, then 4 out of 10 means that the probability will be equal to 0.4. Let's have a double check and see if Miss Liu wrote the same thing. The first outcome is getting a dog, and this has a probability of 0.4. Random numbers 1, 2, 3, and 4 represent a dog because 4 random numbers out of 10 matches the probability of having a dog. 4 out of 10 equals 0.4. So what you'll do is you'll just do that same statement for each animal. But you may want to make it, just put it into your own words. So I'm going to go, all you do is just change this for the next one. So cat is 5 to 7. Change this to cat, because there are 10 numbers total. And if 3, because the cat's got 3, then for cat, it's a bit dangerous doing this. You might want to just write it out again. Then 3 out of 10 the probability is equal to 0.3. So you just do that for all of the pets. What else do we need? So it's always about checking this marking grid over and over. So I need so I've got probably a merit now, but I may want to double check it. But now I want to start looking for an excellent. So I'm going to need a second assumption, and effect of at least 2 assumptions on the simulation has been explained. Ooh, now we're getting into some pretty tough territory. So I don't really want to give you a concrete example, otherwise everyone will just copy what I do. So I would probably put this under my assumptions section again. That's another assumption. I am assuming that a pet shop will have at least many of each animal. Some pet shops may only have 3 dogs. This would mean that once the family selects 3 dogs randomly, that they wouldn't be able to get a 4th dog and may have to choose another pet instead. Right? So what does this mean? So what they want to do in the marking grid is effect of at least 2 assumptions on the simulation that has been explained. So this would affect the simulation. Oh, I think it's affect. No, I'm just saying affect. The simulation because in real life they wouldn't have an option for a fourth dog, whereas the simulation doesn't take this into consideration. It merely assigns randomly. Right, so this could be an effect that it has. So that there's pretty much us going through the plan and the data and the analysis in this video. So I'll make another video that goes through the next section for the pet data. All right, so in the next section, we're going to have a look at the analysis and the conclusion. To be honest, I should probably just finish it right now, but this video has been so long. Let me just have a quick look at how long that part takes. We got that, oh, we've already done the analysis. Oh, maybe we're all right. Let's just have a look at Miss Lou's and we'll just finish off using that, eh? Okay, so she's got her one here, and we'll just have a think about what the merits and excellence parts might look like. So she's got her one, see how she's done these already. She's got this one small assumption here, so maybe my assumption was too big, and you could go for something a little simpler like this. She's got her link in here, she's got her screenshot, nice. There's also a video there, so you can find that on the PowerPoint as well. She got this. She got the probability of yes, having all 4 pets and 12 pets or fewer, being 28 out of 50 in her one. So see how she's counted that up and found these here. So she's written here a proper statement, 28 out of 50. So we need to write that in ours as well. And let's see her conclusion. Out of the 50 trials that I run, 28 trials contain all 4 different types of pets with 12 pets or fewer. Therefore, the probability that the family gets all 4 types of pet with 12 pets or fewer is approximately 28 out of 50. So in her simulation, she found that 28 out of 50 times that is when they got all 4 pets. But the thing is, if I was to do my own simulation, I'll probably get different results because it's randomly decided. So there's this thing called sampling variability, and it's if we do the same thing again. So if she takes 50 trials and if I take 50 trials, it's going to be a fairly similar result. So it'll be maybe around about 28 out of 50, but it's not often going to be the same. So we have to have this conversation about sampling variability. If I do another simulation, what will happen to my result? Stay the same or different, and why? You may start your sampling variation using the probability of 28 out of 50 that I found in my simulation that the family gets all 4 different types of pets with 12 pets or fewer is just an estimate. If I did another simulation with the same number of trials, I may find that it is a different result, right? But that happens whenever we're sampling, whenever we're doing trials. Okay, so then we're going to so let's have a look. What does that mean in our marking schedule? Right, so we've got that analysis. She found that probability. You have to have a discussion about sampling variability. And she also concluded, she made her conclusion up here. Right, so then you talk about sampling variability. And if you want to go for these higher grades, you need to have some insight shown, and you need to have a discussion in context of how you could improve your simulation, what are some of the limitations, and then you could talk even more about sampling variability. So you could just Google sampling variability and then talk about it in context. So that's the whole internal assignment. So yeah.